Good morning. Can you hear me?
Yes, doctor.
Yes, doctor.
Okay. Confirm with me. Can you see the screen?
Can, doctor.
Okay. So let us start. Today's chapter is chapter 7. The reason I'm doing chapter 7 now is because I want you to guys to continue your assignment. So today's chapter is regarding correlation and regression. So what is this correlation and regression? Basically, correlation is before we go through the slide. Correlation is to measure is a measure to indicate how strong, measure to indicate the relationship between two variable. In this case, in this syllabus we take only two variables. Okay, so it's a measure, is a number. Okay, it's a number. We're going to calculate a number. How we're going to do the process of correlation is by measuring a number to indicate the relationship between the two variables. Okay, now let's say for example, you have a number of burger. Number of burger eaten by somebody and is weight. Let's say the number of burger eaten somebody is 3, 4, 2, 5, 6 and 1. This one would be 60, 65, again 60, 70, 78, 55. Okay, let's say these are the two variables. Two variables is here. One is number of burger, another one is a weight of the person. So we can assume that well, let me ask you a question before I proceed. Which one will influence which one? Okay, we have number of burgers here and weight. Does the number of burger influence weight or weight influence number of burger?
Burger influence weight, sir.
Yeah, the number of burger influence weight. So the one got influence is weight here. This will be your y, and number of burger will be your x, which means you have to use your logic here. In this case, this is your y and this is your x. In other words, x is independent variable and this one is dependent variable. Okay, this is just one example I'm giving you. It's not in the slide. So if we want to measure how close or how strong is the relationship between this number of burger or weight. In other words, how much the number of burger influence the weight of a person. We can do that. Actually, we can measure that measurement. Okay, we can quantitatively we can explain certain relationship between two variables. Right. So how to do this? First of all, I would like to plot the graph. Okay, I would like to plot a graph based on these 2 points, whereby my number of burger is x, my weight is y, so my coordinate will be like this. Plotting, remember, when you want to plot in Cartesian plane, you need a coordinate. So the coordinate will be 155. This one will be 675. This one will be 5 70. Okay, so this would be my coordinate. So to see the relationship between these two variables, I'm going to go down a little bit and I'm going to draw this. Let me erase this. I'm going to draw properly. This one I erase this. So this would be my x, this would be my y. You can also write here number of burger, the weight. This one, number of burger. Now this is 0. So if I start with 1, 2, 3, 4, 5, 6, I'm just want to plot and see how the data represent in a Cartesian equation. And my highest value for y is, I can go up to 80, so I can put here 40, 80, 60, 70, 50, 20, 30, 10. Now if I want to plot this, 155 is here, and another one is 680. You can, it doesn't matter order. Okay, it doesn't matter on order. You can start from the top or bottom, as long as all the points in the Cartesian plane. 6, okay, 570 and 260, 465, 4 here, 65 is here, and 360. Yeah, this would be the 6 points if you plot in a Cartesian, which of course this is just a sketching or rough idea. Okay, I'll give you some time. You copy this first. Once done, let me know. Remember, today we have a tutorial, so we will go through this chapter today, and I will explain to you regarding the assignment. Okay, so if you see this, I suppose most of you have copied. Okay, again, those who came late, let me recap how I started. I have started with correlation. We're going to learn two things today. One is correlation, another one is regression. Correlation is a measure to indicate the relationship between two variables. It can be weak, it can be strong, something like that. Measure means we're going to compute a number. Okay, later on we will do that. For example, whereby this example is not in the slide, I give you one example first: number of burger and weight. So here the first question I ask is, which one influence which one? We have two category here, number of burger and weight. So clearly number of burger will influence your weight. The amount of burger you eat, that will influence directly your weight. Okay, it's supposed to be like that. But how much this number of burger influence your weight? How strong is the influence? We're going to compute that. Okay, later on we will compute that. Before we computing the measurement, normally what we will do, we will plot the points in the Cartesian plane like this. Okay, it has a special name for this graph. It is known as scatter diagram. Okay, you can see in your slide, it is known as scatter diagram. The scatter diagram is simply a plot of data points on x and y graph. So if a scatter, once you plot a scatter thing, if it has a pattern going increasing, see, you can see a pattern here. If you see a pattern, if you can see this one going upwards, increasing, then you can subjectively conclude that it has some relationship. Sorry, but sometimes when you see the first graph, look at this. You see this one, when you plot, you see all these points falls on a straight line. This is a very strong relationship. We call this a very strong correlation. You see the second one, 4.3, figure 4.3. This is a little bit scattered, which means is weaker than the previous one. And you look at this straight line, no relationship at all. Okay, this one a little bit scattered, and this one going downwards, a little bit of relationship. So how are we going to measure? Is there any number can represent this scattered diagram? The answer is yes. It is known as Pearson coefficient of correlation. Okay, Pearson's coefficient. We will denote it by R. Okay, I'm referring to the slide now. So the R is the measurement of degree of scatter between two values, as I told you. The R is the measurement whereby it tells how scatter is your, how selara, what do you call selara in Malay? I can't recall. But how scatter is that between two variables? The coefficient which we're going to find is always between -1 and 1. You can see here, if all the points fall in a straight line, then the R, the coefficient which you're going to compute, is 1, exactly 1. If the coefficient is exactly 1, then all the data falls in a straight line and it goes upward, which means as x increase, y also increase. So, okay, if R is 0.8, then it has some relationship. You can see this one is going upwards also. Okay, it's going upwards. But let me draw here. You can see this one going upwards. This one is exactly in a straight line, exactly. So it's very strong. Coefficient is 1. This one is not exactly on the straight line. It's scattered a little bit, so it reduced 0.8. You see here, as x increase, the y also increase. This one as x increase, this y also increase, but little bit. Okay, I mean the first one, the previous one is better, more accurate. The second one is what you call less accurate from the first one. Third one, you can see as x increase, the y is stagnant, not increasing, not decreasing, is that. That's why the line is like this, stagnant, tak bergerak, stagnant, increase. So if the x increase, the y doesn't move anywhere, the R is 0, no relationship, nothing. The x doesn't influence the y, nothing happened to the y. Here x increase, what happened to the y? Y also increase. This one x increase, y also increase. So the x does influence the y. Here does influence to a certain extent. This one no at all. Same goes here. This one we cannot say it is 0. It is little bit increasing, something like this, or we can assume that this is increasing little bit, so that's why it's the positive values, that's 0.3, and this one is decreasing, and you will have a negative value for R. We will compute that. Okay, so for a strong relationship, if a line goes like this, okay, the dot, the plot is exactly on the line, something like this, or this is positive r, r is positive, or r also can be negative, and the plot is on the line, both are strong actually, both are strong relationship. Doesn't mean positive is a strong relationship, negative also a strong relationship, as long as the points are fall to a straight line. As long as the points, the one you plot, tends to be in a straight line, then it is a strong relationship. The further it goes from the straight line, it is a weak relationship. If you go further in the slide, you can see here I have written the explanation here. If r equal to 1, it is called perfect positive correlation exists between two variables. As x increases, y increases. So here, as number of burger increases, your weight also increases. That's how we have to explain in the question or in the assignment. Later I will explain to you in the assignment what to do. That it is quite easy. You can do faster and you can submit faster. If r is in between 0.8 and 1, strong positive correlation, focus on the word, this one is perfect, this one I just use strong. If strong positive correlation, as x increases, y increases, positive number, as x increases, y increases. 0.4 to 0.8, moderate, still positive, and still x increases, y increases. Here, if r in between negative 0.4, did anybody ask any question to me? No, okay. If r is in between negative 0.4 and 0.4, very little correlation. That's all. Nothing increase, nothing decrease. No need to write that because we cannot conclude when r is in between this. Now, if you see this one 0.4, 0.8, as x increases, y increases, and it is moderate positive. If it is negative, then we call it moderate negative. As x increases, y decreases because negative. Remember that. Okay. As x increases, y decreases. How it goes? It goes like this, downwards, negative. Okay. And strong negative decreases, perfect negative decreases. Okay, I hope you guys understand. There are 1, 2, 3, 4, 5, 6, 7 category are there. So we're going to compute the number now. What is the formula? The formula is given here. Of course, it's a big formula, but this formula is given in your final, so no need to worry. Let us look at one example, and you guys will do one exercise. Okay. All right. Look at this example. This is the formula. Formula, of course, you can always refer to the formula. Anyway, our aim is to find. See, R. For us to find R. What is R again? R is actually Pearson coefficient. Pearson coefficient will tell you how strong is the relationship. For you to find R, you need to find R square first. That is the formula is given here, R square. Then from R square you will find R. The R square itself, it has a special name known as coefficient of determination. I will explain to you what is these two are and how to explain that. Everything will be given by today and you can do immediately your assignment. Look at this example first. Read this. So if you read this, this is a table shows advertising expenditure and associated sales of particular product. Find R and comment on the association between the two variables. In this case, this is your company sale. You are selling some product. Okay, this is your sales, and this is the expenditure for your advertisement. In this case, expenditure of advertisement influence your sale. The more you advertise your product, okay, it's supposed to be like that. The more you advertise your product, the higher goes your sale. Am I right? The more you expose yourself, expose your company to the public, the more people will buy your product. So that's how it goes. The more you spend for the advertisement, okay, this is your X. The more you spend for your advertisement, this advertisement expenditure will influence your sale. Okay, this is your Y. So first identify your X and Y first. Normally in the question I will give you X the first column, Y second column. Okay, don't worry, but in this example I give you the other way around, just to make you think that it is not always the first column is X. Now once you know X and Y, all you need to do is compute this thing. Okay, you need to compute what? Summation of xy, summation of x, summation of y, summation of x square, summation of y square. So you will put a table like this. Just have a look at this table. Okay, you can see that this is your X, this is your Y, and how to find X square? 8 times 8, 64. Y square, 625, 25 times 25, and XY, 25 times 8. That is the first row. You have to do each and every row like that, and then find the summation. This is a summation here. Take the summation. Your n is number of row, okay, number of pair of data. How many pair of data are there? 1, 2, 3. I'm using my mouse while I have my pen. This is your X. This is number of data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equal to 10 in the formula. Your n is 10 here. Okay. Once you get all the summation here, I suppose this is in your slide, isn't it? Is this in your slide? Did I share this with you?
Yes, doctor.
Yeah. Okay. Now once you do this, you substitute all the value there inside there. Okay, you substitute the value, you will get the number 0.94. Okay, you substitute, you will get 0.9482. 0.9482, where is it false? 0.9482 is false here. Strong positive correlation between the two variables. So right here, strong correlation, whereby your explanation should be like this. Two variable, as expenditure increases, sales increases. That's all you have to write. There's another explanation when we do this one exercise on tutorial. I will explain to you that. Now remember, I want to highlight here something. When you, okay, so far so good, everything. You just substitute in the formula, find this one and substitute in the formula. Okay, any problem? Okay, you guys can ask me because I'm going to explain later in the assignment. All you need to do is identify x and y, compute this summation, substitute the summation inside the r, and you will get this. Actually, you have to compute r square first, then only r. We will do one tutorial later, and you will understand more. Now, the problem is when you do square root, normally when you do square root for this is actually plus minus 2, am I right? It is not only positive, it can be take negative value also. So here it can be plus minus, but I take plus only. Why? Because if you plot this data, you can later try later. You can. Did I plot this? Anywhere I plot? No. If you plot this data here, okay, your plot will go upwards. Okay, you can see a line going. It is moving upwards. When it moves upward, remember the gradient is positive. Remember this one, gradient. If it goes downwards, then the gradient is negative. So if once you plot, you see the pattern. If the plotting goes upwards, then your R is positive. If the your R is positive. If your plotting goes downwards, your R is negative. Where the positive negative comes? From the square root here. So choose wisely, positive or negative. For that, you need to plot the data. Okay. Now, I hope you guys have this slide. I give you some time. What you have to do? Can you guys do this exercise? Try do this exercise. Temperature. Okay, before that, temperature and ice cream sale. Temperature and ice cream sale. Can you tell me which one is which one influence which one?
Temperature influence ice cream sale, sir.
Yeah. So this would be your x, this would be your y. Now continue. I'll give you some time. Compute for me the what do you call the r for me. You can also sketch little bit. Later I'll show you the whole thing. You sketch little bit and you can see the diagram. I give you some time. Try for this data and I'll give you the answer later. Hello, Andy. Jaya ni nanti kita mau book 2 kot boleh 7 9 hari ni. Sebelah lah 9 8 lah bagi. 9 8. 7 9 Okey okey. 2 kot okey. Okay, some of you have done. Waiting for more answers from you guys. Let me receive more answer here, maybe 5 to 6 answers. Yeah, the answer is 0.9575. Huh? You should get 0.9575. Let me, I'm waiting for more answers. All right, any of you get good? That's good. So if you see here, I use Excel to just speed up the teaching. Of course, I can show in the class. If in the class we can show in the computation, but due to time limitation, I need to use Excel. So your answer is 0.9575, and if you plot, you can see the line is going up. Okay, the pattern is going up, so of course it is positive. If it is going down, it is negative. All right. Now my question is, if you see this okay, we have done here. Okay. I hope all of you get this. Okay, all of you get this. Still trying. Some of you still trying. So our aim is, the first aim was correlation. Okay, the first aim was correlation. The second thing is regression. Okay, what is regression? Regression basically is a line. Okay, linear line, linear equation. Regression is a linear equation. How linear equation look like? Y equals to, did I open the mic? Yeah, okay. Y equal to mx plus c. Your m is gradient. I don't need to teach you this. This is form 5. This is y-intercept. So if you plot a graph, the correlation is how strong is the relation between this plotting. Okay, so by the number we compute, we can tell that these x and y, how related they are, how much x influence y. Okay, we can tell that. Regression, remember I tell you a pattern, isn't it? Pattern means which means it goes up, means like this. Regression is all about finding this equation of line. Okay, so we're going to find a proper linear line which can represent that scattered diagram. That is called regression. Okay, you can see here regression is a linear equation or linear model. Okay, here your A, I use A here for C. Okay, this is C, but you can also write like this, no problem. A plus bx. What is your A? Is exactly the same with this. What is your B? Is exactly the same with this. The coefficient of x is gradient, and the constant, the one without x, is your y-intercept. That's what I have written in the slide. So basically we're going to find the regression line. Okay, how to our aim is, we know each scatter diagram. When you scatter some diagram, you can always find. So from now onwards, I will use A and B to just make yourself convenient. How to find this A and B? Okay, for that you use this formula here. Okay, your B is this, your A is this. This is the formula. So for the previous examples, expenditure and sales, you can notice that your B is 2.14. Okay, I hope all of you have the slide. Maybe I'm going a little bit fast, but I hope all of you have the slide. You can refer to the slide here now. I'm here now. How to find B? Again, substitute the value. We have found the summation, and for A is this, and you write back again your A and your M here. Okay, now what I want you to do, just now we have this one, isn't it? Temperature and ice cream sale. Can you find the regression line? Use the summation, same summation you have. Use your same summation and put inside this formula A and B and find me the line. Try and tell me what is your A and B. Tell me what is your A and B, and maybe you can write also the line straight away. If you guys don't understand anything, if I'm going too fast, you don't understand, please open the mic and ask me.
So is B negative?
B. Okay, let me check here. A negative, not B.
I mean A is
Yeah.
A negative.
Yes, A negative. Write the answer here. Let me check. Your A, I think your A should be negative 159.47. Your B is 30.09. Somewhere here. Double check. You should get this. And your equation is, when you want to write the equation, y equal to negative 15, you can write like this, 15.4 plus 30.0 x, or you write this one 30.09 x plus let us write like this. Let us write like this. Let us write like normal thing. 30.09 x minus, okay, see whether you get this or not. Yeah, good. One of you get it. Anybody else get B and A? Anybody else get B and A? Just need some confirmation. As long as you can compute correlation and regression, then the later Later explanation I can give you in the tutorial afterwards. Anybody get it? A and B? Still doing? Use the previous one. I don't know whether you guys are doing this one, eh? Okay, exercise still, we are still in exercise class 1. Use this data to compute A and B. If anybody use this one, don't use this example, eh? Use this one, A and B here. For this example I already give you. This one also don't use. Humidity and moisture and content, that one later on. Use this one, the ice cream, the one you have done before. Just replace in the A and B. Only one of you are getting. Your B should be 10. Summation of EX XY is 9595 95506. Minus.
Doctor, I thought N is 12, not
Sorry,
10.
N is 12, yeah. Summation of X 224 4829. So what do you get here? Yeah, you're getting B here, you are getting here you will get 30.08786 something, so you round off to 2 decimal places. So A is summation of y (12). Your B is, just now you compute, I take 4 decimal places. I think I have mentioned this earlier from the very beginning. If you want to use a number which you have computed before, you use 4 decimal places to get accurate number. This is again 12. And you will get here, yeah, so your A is 159.47. okay, so your Y is 30.0x 15947. okay, this is how you compute your regression line. The use of this regression line I will explain to you in the tutorial. Okay, so we have computed the coefficient of correlation. We have done correlation. We also have done regression. Regression basically is finding a linear line which represent the data. Finally, another guy got it. Another, sorry, not guy, girl. I'm Najla, sorry. Alright, so I will stop here. For this class, I aim to finish teaching you how to find correlation and regression. Further explanation regarding this will be given when we do some tutorial question later on at 11 and 2. So I'll see you guys at 11 and 2 again, and we will go through some instruction on how to do and submit your assignment to me. Alright, with that, thank you very much. I'll see you guys in a while. Take care and stay safe. Bye bye.